Good afternoon, everyone. I welcome you all to this Mission Life webinar on Reduce E-Waste. Every year, we generate millions of tons of electronic waste from old cell phones and computers to television and appliances. And this waste is not only an eyesore, but it also a threat to our health and environment. I now request Thiru K. Kalamegam, Environmental Engineer, Department of Science, Technology and Environment, to deliver the introductory remarks about the webinar.
Good afternoon, everybody. Am I audible?
Yes, sir.
Okay. We are here today because we care about our planet. And we know all those old electronic gadgets like phones, chargers, and laptops we toss out. They are not just a junk. They are hurting our planet and destroying our environment. We know this well. Making these gadgets uses tons of energy and leaves a significant carbon footprint. Dumping these wastes pollutes our land, water, and air. So, how does Mission Life, launched by our Honorable Prime Minister to combat climate change, help to save the planet from the massive electronic consumption and e-waste dumping? One of the core theme of Mission Life is reducing e-waste. It's about the small lifestyle changes we do every day by limiting our choices of electronic gadgets wisely. When we stop throwing away old electronics, recklessly, we choose a future that's sustainable in every way. Uh, and we enable clean air to breathe, healthy nature all around, and a planet alive with plants and animals. This is all possible in a way by reducing the electronic consumption and disposal. Mission Life is about making choices that matter, one gadget at a time. Mission Life is all about choosing a better way and means getting smart about e-waste. India is already doing some good things like using solar power and reducing more e-waste, but we need your help to make a real difference. During this webinar, we'll learn from our expert, Mr. Devanandan, Assistant Environment Engineer, Pondicherry Pollution Control Committee. And I request to engage in a meaningful discussion, swap ideas, and collectively shape a future where responsible e-waste management becomes the norm. We'll talk about how to make our gadgets last longer, pick gadgets that are better for the planet, and recycle the ones we can't use anymore. Remember that even small changes can add up to something big. So let's start by turning off our chargers when we are not using them, fixing things instead of buying new ones, and choosing brands that care about the environment. Mission Life isn't actually being perfect. It's about making choices, smart choices that can contribute to a better environment. It's about using technology to make our lives better, but not at the expense of our planet. So let's join hands and pledge to reduce e-waste together. Let's show the world that we can have all the cool gadgets and a healthy earth too. Thank you. And let's get started on this crucial webinar.
Thank you, sir. I now request Tirthi Balaji, Senior Project Associate, Puducherry Climate Change Cell, to introduce our today's expert.
Thank you. The speaker for our webinar today is Mr. S. Devanand. I'll introduce the speaker to the participants. Mr. S. Devanand works as Assistant Environmental Engineer in Puducherry Pollution Control Committee since the year 2018. Prior to this, Mr. Devanand has worked as the Project Officer at IIT Madras, working on area in air quality monitoring, modeling, and pollution abatement. He has worked on diversified pollution abatement areas like air quality assessment, industrial effluent treatment plant, especially in textile industries, zero waste management for solid waste, electrochemical degradation of textile wastewater and domestic sewage, and many other such projects. He has also worked as a lecturer at NIT Karnataka. With his area specialization as e-waste disposal and management, he has published over 10 research papers in various journals, and has also participated in various conferences and workshops. He has received the Young Scientist Award by the International Solid Waste Management Conference at Infosys Mysore. Sir, pleasure to have you as a speaker today. I welcome you once again. You may start your session now.
Thank you, Balaji. I now request Thiru S. Devanandam, Assistant Environmental Engineer, Puducherry Pollution Control Committee, to give the presentation on reduce e-waste. Sir, you can share your screen, sir.
Are you able to view the presentation? Hello? 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 Am I audible? Hello?
Yes, sir.
Sir, you're audible.
Okay. Thank you. Thank you. So, very good afternoon to one and all. So, today I'm going to give a lecture on e-waste management. And as a part of LiFE mission events and the Reduce e-waste team, I'm presenting it today. So, my title slide itself, it's clearly visible that I'm going to emphasize on circular economy. Uh, we have been used to a lifestyle where use and throw, but now we have to come up with a new lifestyle that is circular economy. So come up with a lifestyle where the gadgets which we are using has to be sustainable and have a prolonged lifetime, and then we are able to reuse it for further usage. So the figure itself shows that industries manufactures, and then we consume and we use it, and then it goes into a waste, whereas the waste again it has to be used as resource, and then which goes into the manufacturer. So this is in general circular economy. So let us see in our further slides that how this we are incorporating in e-waste management. So first let us understand what is e-waste. So e-waste in general, we all know that any discarded electrical and electronic products. So discarded products are generally we discard it only when it has a repair or we are unable to use it, or in lifetime of the gadget is over, or else outdated models. In recent days we may be aware that the last past 10 to 12 years there is a huge shift in the mobile phones and tablets, and even like a lot of electronic devices in our daily lifestyle usage, where we have been using adapting the mobile phones gradually from year to year, because every year we are getting a new updation, and then new kind of specs in the mobile. So we tend to gradually move with the lifestyle, but which itself indicates that there are a huge amount of waste generation in our lifestyle, and then which may also cause an impact in our later stage. And the another definition is e-waste can also be components or spare parts of electrical and electronic products. So we also have to understand that mobile, it's a not only electrical and electrical product, even the charger which we get, it's a part of the mobile. Without charger we cannot use the mobile phone. So even the charger, if it becomes a waste, then it is also considered as an e-waste. So that is the reason the definition has included the every each spares and consumables. So let's see statistics that as per global e-waste monitor, it was predicted that there will be a 3 times increase in the generation, that is from 18 lakh to 52 lakhs metric ton per annum by 2020 in the e-waste generation in India. And similarly, the majority of the waste generated, if you see, 70% includes computers, IT products, followed by telecoms, 12%, and electrical 8%, medical 7%, and miscellaneous household e-waste 4%. And similarly, this e-waste reprocessing market in India have a higher worth, that is predicted to be 1,900 million actually, and which is expected to reach 5 billion by 2020 if it has been formally addressed. And you can see the figure that where they have shown
Sir,
the
1 second, sir.
yeah, yeah.
Sir, your presentation slides are not changing, sir.
Is it now changing? Presentation slide model.
And the side I use processing statistics.
Okay, thank you. So the figure itself depicts that what is the per capita waste generation in e-waste. So you can see the European countries are higher capita, whereas India comes in the bottom five. But however, in the Asian country, if you see, we have a larger population compared to European countries and American nation. That is the reason we are generating higher volume of e-waste, which can be shown in the next slide. So this slide presents the total quantum of e-waste generated by different nations. If you see America, they have 13.3 per kg per person, and the total quantum they are generating up to 13.1 metric ton, out of which 1.2 metric ton is recycled and 9.4 percentage that is. And Europe, if you see, the quantum of generation is 12 metric ton, and the per capita generation, if you see, each person will generate 16 kg of waste, and 5.1 metric ton is being recycled by Europe, and the highest recycling efficiency they have, that is 42.5%. When it comes to Asia, we have a generation of 24.9 metric ton, but whereas second lowest per capita generation we have, that is 5.6 kg per capita when compared to other nations. And the recycling efficiency, if you see, it's almost 11.7 percentage. And similarly, Australia and New Zealand, Oceanic Islands, you see they have a 16.1 kg per capita generation, and whereas the volume of generation is less because there might be the population would be less, and similarly recycling, if you see also, if comparatively it is less. And let us go through the informal waste processing. So there are two types of issues we are facing. That is, one is informal e-waste processing. As you can see, India is only recycling 11% of waste, whereas somewhere the e-waste getting leaked, which goes to the kabaddi wallahs, and then day-to-day rack pickers are collecting it from the households. So these reasons the e-waste gets leaked to the informal sector. And what happens to these e-waste once it reaches them? They try to do informal recycling or through melting or breaking the electronic products, which in turn affects the health and also affects the environment through impact on soil, water, and environment. So some of the impacts I have majorly shown here. One is that some studies found that higher level of brominated flame retardants were found in human breast milk based on samples collected in various area near municipal dump sites, and also uh, in Mondoli, Loni areas around Delhi, where there are more than 100 informal e-waste processing units were there. There is a high levels of lead, cadmium, nickel, mercury, and hexavalent chromium and zinc were found in soil and water samples. This is majorly due to informal breaking of the electronic products without any proper management. And you can see that these metals and chemical compounds are known to cause neurological disorder, lung cancer, and malfunction of vital organs in the human body. So let us see in detail what are the various hazardous substances can come from the electronic products and what would be their impacts. So you can just see the chemical substance, halogenated compounds, and chlorofluor compounds, PVC compounds. The second column says about the source of e-waste, from where it is been emitted, and then what are the impacts on the human health system. And similarly, there are also heavy metals also leaching from the e-waste due to improper management. You can see arsenic, barium, beryllium, cadmium, and chromium 6, gallium arsenide, lead. These are the some of the heavy metals which have been emitted during improper management of the various electronic devices. The second column shows from where it is being generated, and third column shows what is the impact it causes to the human health. So this shows us that there is a keen importance has to be given to the informal sectors, and then what is the level of impact it can cause to the people working in the informal sector. And similarly, there is also other heavy metals: lithium, mercury, nickel, selenium, zinc sulfide, and other organic substances. Toner dust. Everybody in the office, we might be using the printers, and there are a lot of toner dust which are very fine in size, which get inhaled when it is not being properly disposed. And radioactive substances from medical equipments and fire detectors are also possible. So uh, I'm going to give a glimpse of informal e-waste processing sector. What is actually happening? Uh, so generally, in informal e-waste processing, they just collect and break using a hammer or any other.
Excuse me.
Yeah, yeah.
The presentation is not running. Still, it is not in the presentation mode.
Okay,
We
okay.
can see only one slide from the. No, it is not. It is not put in the presentation mode. The slides are not moving.
Santa. Is it visible now, madam?
Yes, sir, it is visible.
As the slides are changing, are you able to cope up with that?
Yes, sir.
Yes, it is. Yes, it is visible. Slides are moving now. Thank you.
Okay, madam. Thank you. Sorry for that.
No, no.
So, I was talking about the informal e-waste processing. So, in informal e-waste processing, these are the glimpse how they are processing that electronic e-waste. In general, they collect it and then they process it using a hammer or a heavier substance, and then they break and separate the PCB board separately, and then from the PCB they separate the capacitors and other things, and wires being separated, because they are very skillful, as they know where the the metals which they require, where it contains. However, the skill is being used in wronger way. They, as it is not helpful to them also. And these are some of the points I want to highlight. No protection for the workers. There are dust toxins emitted during open burning of the waste, and also it affects their health. And they don't have any valid license from Pollution Control Board or for any legal manner, and which is a low cost recovery method. And that is the reason they are majority of the e-waste getting leaked to illegal sector. And the problem with the informal sector is our collection, handling, storage, which are being basically handled by unscientific methods, and inefficiency recovery of resource carried out in open area within settlements, and no protection of environment and own health, and handling of all these hazardous chemicals to retrieve valuable metals and emission of toxic gases. And these residues just remain in the floor or in the soil, and they get moved to the drains during rain, and then which get again impact on the soil and water. So these are some of the images which shows how they are doing. This is melting of the metals, and then they're pouring it in the copper bar or aluminum bar. And this is recovery of gold, where they use acid to separate the gold, and then they use it for they sell it for the valuable resource. And here the metals are being extracted using acid, and they form it as amalgam, which is again from the amalgam they separate different metals. And these are some of the plastics in electronic products. As we know, all our laptops, and then our system, and then printers, they have all plastic body, and there is variants of plastics actually. We all know that styrene, polypropylene. In addition to that, there are a lot of variants, ABS, those kind of plastics are available in the system, which are basically flame retardant plastics. And so they segregate it, and these people recycle the plastics also in informal way. So which can be seen, they have been washing the plastics and other things. So they're melting it and then forming it as some useful product. So these are plastic sheets. Once it is been shredded, which is being reused for forming some other products. So here they are extracting coppers by burning the wires, which you can see. They are cutting it and then trying to extract the metals within that. And you can see the outer parts are lying on the floor actually. So these are some of the incidents which have been brought to the notice. As we all know, Moradabad in UP, which is well known for the e-waste informal sector, and there are a lot of instances that CPCB has taken action. A lot of seizure of trucks has happened. So some of the glimpses which I am being showing here. So this is about informal, and why we have to come to formal. That is what I'm going to stress on it, and how circular economy can impact this actually, and the urban mining of e-waste. So see, all the electronic product will have some kind of metals, and all the metals are may if we start extracting from the earth, and at one point of time there will not be any metal, and which we will be out of the metals. So urban mining on e-waste, that where we can extract the metals through legal scenario and reuse the metals for again forming those kind of electronic products. That is what he is stressing out here. So here you can see various waste from where we can separate metals, plastics, and glasses. And what is the benefit of this? We can the revenue generation from recovered materials can be got, a natural resource conservation. So we are not going to mine anymore for any heavy metals or anything. There will be reduction in pollution as we're directly going to recycle and then reuse the metals to form other components. And awareness to the informal sector. So this urban mining has to be implemented as which is which has a more benefit when compared to the informal sectors. And formal e-waste processing, as we many of them know that e-waste processing has to be formal, but what is actually known as formal? So you can see the photos that which indicates that people wearing gloves, mask, and then caps, and then also they're using screwdrivers. In general, even as per the guidelines, we have to use the screwdrivers to dismantle and then separate the keyboards, mouses, and other machineries. Using only equipments or machinery, we can separate the devices. Breaking or illegal, breaking of any parts of electronic waste is not allowed, which is not considered as formal e-waste processing. So this is how a formal e-waste processing sector looks, and they also have inbuilt dust collectors so that any dust present while processing of the e-waste will be collected and then treated through back filters actually. Let's come to rules. So we have seen what is formal sector and what is informal sector, and what is the shift we need, and how the current rules help us in doing the shift actually. That is what we are going to go through it. Before that, I would like to just highlight to whom the rules are applicable and what are the provisions in the rules actually. So these rules are basically applicable to the manufacturer, producer, refurbisher, and recycler, who generally manufactures the electrical and electronic items. And we already read through the definition of e-waste, that any electrical electronic components which is disposed or discarded is to be considered as a e-waste. And in e-waste, there are totally 108 items are covered under the 7 subheadings. You can see information technology and telecommunication equipments, which covers the our computer, laptops, mobile phones, and printers, all those electrical items. And second one, consumer electric and photovoltaic panel. Photovoltaic itself says the solar comes under it, and consumer electronic, our refrigerator, AC, and then washing machine, and all those electrical items comes under this sector. And similarly, large and small electric and electronic equipment, our ovens and other electrical household electrical items will come under this uh, third list. And electrical and electronic tools, so we use drilling machines and other tools in the industries, and other like electronic tools, they come under this sector. And then toys, leisure, sports equipment, the toys which you use, and then gaming consoles which we are using in the daily, which children are using, all those comes under this. And medical devices also being covered under this categories. And laboratory instruments like gas analyzer in colleges mainly use gas analyzer and weighing apparatus, those are covered under this categories actually. So in total, if you see, there are totally 108 items being covered, and whereas earlier rule in 2016 we covered only around 21 items. So now the current rule is covering a broad spectrum of e-waste actually. So this is the circular economy which I was emphasizing. So how the rules help in bringing back the informal sector to formal sector, and also how we are accounting the generation of e-waste, and how the e-waste is accounting the processing of e-waste also. So you can see that a portal everywhere it is mentioned. Portal is means that CPCB has developed an extended a portal for extended producer responsibility, that is EPR, wherein all the producers, refurbisher, recycler, and manufacturer has to register in that portal. So what happens once they register? They have to produce documents such as like what they are selling, periodical sales of electronic items on quarterly basis. They have to file it in the portal. And what does the recycler do? Recycler will collect the e-waste from the general public through collection points, and he will recycle. While when he recycles, the producer has to uh, see the producer. If, for example, he generates a waste of say 100 kg in 2015, and CPCB sets a target for him that he has to collect 60% of the waste. That is, out of 100 kg, 60% is 60 kgs. So he has to purchase it from the recycler. The purchasing happens like credits, in the form of credits. So the recycler has to collect 60 kgs of waste for the producer and recycle it and file and sell the credits to back to the producer. So this is how now currently the system is being designed. And similarly, refurbisher, you can see a transaction between the refurbisher and the producer, where the refurbisher will extend the life of a device. For example, I have a mobile and its lifetime is say 5 years as per the CPCB guidelines. And if I am extending, if I want to extend, I give it to a refurbisher authorized by the producer, and the um, authorized refurbisher refurbishes my mobile, and he gives the credit that he has extended the lifetime of the mobile to the producer. And this data is also being directly filed to the CPCB, and the credits is being directly purchased by the producer from the recycler and refurbisher. In turn, after purchasing the credits from the recycler and the refurbisher, producer has to file the same to CPCB, stating that he has generated so much of waste, and out of it 60% he has collected for this current year. So similarly, CPCB has given targets for the next 5 years from 2023 to 28 based upon the past generation actually. And what is the role of SPCP PCC? If you see, we verify the actual quantum of electronics that is being sold, and whether he is regularly purchasing the credits. So that is what we are now verifying. And the manufacturer, there's a role for manufacturer also. He is the person who produces the electronic waste. So he also has to file quarterly and annual returns to CPCB how much he is manufacturing for the producer, uh, any electronic devices to CPCB. And here you can see consumer and bulk consumer. So the role of consumer and bulk consumer here is very limited. They have to directly dispose the e-waste to a recycler or a collection point authorized by the recycler or set by the recycler for in order to dispose the electronic waste, uh, so that the recycler can take the accounts of it and submit it to CPCB. So this is the general framework how it is working. The EPF framework is going to work. Yeah, the producer responsibility, which I have detailed earlier, are the same. I have been listed out here. The first, he has to register in the portal, and he will be given targets based upon his past production detail and sales data. He'll be given targets for the next 5 years. How much he has to collect? How much he has to process e-waste and purchase credits from the recycler, and he also has to give an extended producer responsibility plan where he addresses how he is going to collect it, and what he also has to create a lot of awareness. So how he is going to do those awareness and advertisements for creating where the public has to dispose. All those detail has to be provided for obtaining the registration. And similarly, he has to file annual and quarterly returns in the portal for every quarter and the year. And for the manufacturer, he has to collect the e-waste generated during manufacturing. Actually, in every manufacturing company there will be defective products or some manufacturing waste generates. So he also has to report the manufactured e-waste to CPCB, to the portal, and file annual and quarterly returns on how much he is produced or sold. And similarly, refurbisher also has to register on the portal, EPR portal, and he has to detail on how much e-waste generated during process of refurbishing. Even during refurbishing process also, there will be some parts which is in repair, so they replace the part with a new parts, and then the part which come as a discarded item has to be disposed to recycler properly. So they also have to furnish reports to CPCB that how much is e-waste is generated during refurbishing, and how much they are how many electronic products they are refurbishing for the producer. So that is the reason they are filing annual and quarterly returns in the portal. And finally, recycler. So recycler has to maintain records for how much is collecting, how much is dismantling, and how much is recycling, and all records has to be available for verification and for the audit. And he has to find annual and quarterly returns how much he is recycling, I mean converting into valuable metals, and then how much the waste he's selling it as a credit to the producer. And also he has to accept all the electrical and electronic components listed in schedule 1, and even if they are not listed in schedule 1, he has to accept so that the waste goes to a proper recycler. And he also has to create awareness through media publication, advertisements posted by such other means of telecommunication. So finally, we come to the consumer and bulk consumer role. Uh, so these are some of the list of bulk consumers. So as we all know that all the bulk consumer tends to produce discarded electrical and electronic items. Like after a period of their end of life, we have to dispose it. So as per the rule, we have to dispose it to the authorized refurbisher or recycler by the producer. So it is responsibility of every bulk consumer and consumer to channelize the waste to the proper refurbisher or recycler to ensure this circular economy is working. So, and this is some of the collection center. That is one. There is only one collection center in UT of Puducherry, and whereas the neighboring state there are recyclers which have provided the link from where we can collect the e-waste recycler from the neighboring states. And people who wish to dispose the e-waste, they can contact the contact number which is given here, or they can contact us so we could help the consumer and bulk consumer to dispose it, channelize it properly to the authorized person. So with this, I complete my presentation. Thank you for giving the opportunity, and thank you to the entire team of Climate Change for giving this opportunity uh, for sharing my knowledge.
Thank you, sir. It was a very informative presentation. Participants, if you are having any queries, can ask to sir. Okay, then we'll move on to the vote of thanks. I now request Tirumadi S. Santalakshmi, Senior Project Associate, Puducherry Climate Change Cell, to deliver the vote of thanks for the webinar.
Good evening to one and all. Am I audible? Good evening to one and all. I thank all the participants for joining in the today's webinar. And also I thank our speaker S. Devanandan, Assistant Environmental Engineer, PPCC, for sharing very insightful knowledge on e-waste management and its environmental hazards and the responsibilities of all the stakeholders of e-waste management, etc. Thank you, sir. And also I thank our director for his support in organizing such webinars. And I thank all our colleagues for joining in this webinar. Thank you all.
Now we'll wind up the session. Thank you for all the participants for joining this webinar.
Thank you, madam.